Hello, my name is Stephen Thomas and welcome. Today I'm going to show you how easy it is for anybody to install the new GPT-OSS large language model using Ollama. This model has two versions. One version is a 20 billion parameter version that requires 16 gigs of RAM to operate. The next is a 120 billion version parameter model that requires at least 64 gigs of RAM to operate. Now the process is exactly the same to set up and install either version of the model. In this demo, I'll show you how to use the 20 billion version parameter model to set up and run on an Azure Virtual Machine. The 20 billion parameter version is designed to run on a laptop, so almost anybody watching this video can follow these simple instructions and be up and running a large language model locally. No fancy GPUs are required to run this demo. Now you will notice an impact on speed and performance based on your hardware. Before we get started, why would you want to run a large language model locally in the first place? First off might be data governance. You might not want your data calls being made to remote APIs off of your network. Running your model locally solves this problem. Second might be edge case scenarios where you're running on hardware that might not always have access to the internet. And the third reason may be costs. Running a large language model locally does not incur a per token cost. Now you do have to pay and set up the hardware that your model is going to run on. I imagine for most scenarios, the first 2 points are the key drivers for running your large language models locally. I should point out that the GPT-OSS model is an open weight model. This means the model itself is not open source, only the parameters are. This still allows you to share, train, and run the model locally. This is in contrast to the DeepSeek R1 model, which is a true open source model. Let's jump in and see how easy it is to set up GPT-OSS locally.
Okay, let's jump in and see how easy it is to get the GPT-OSS model set up and running locally. Now I'm running on an Azure Virtual Machine here. Now this doesn't have a GPU, it's just all CPU based, and I'm running 32 gigs of memory on this environment. Now I have set up the 120B parameter version of the model on my local environment. Now that does have a GPU and 96 gigs of RAM, and everything ran just fine. For the purposes of this demo, I'm just going to run it on this environment with 32 gigs of RAM, and we're just going to use the 20B version of the model. Now to get started, I just go to Ollama, and right here I just simply click download, and this is going to download the latest version of this program. If you've worked with Ollama in the past, it used to be very much command line based. They've upgraded it recently so you can download and install all the models directly from the GUI, which is super nice if you don't like to work with command lines. Now once that's downloaded, I'm simply going to click that download link and install this program, and I'll show you a few of the steps here as we get started, and simply click install. And this whole process to install this takes about 2 minutes. So I'm going to go ahead and pause the video and jump right back in once the install is complete. Now once the setup is complete, it automatically opens the Ollama interface, and this looks very similar to other ChatGPT based interfaces that you might be experienced with. I do want to jump over here and show you some settings. It's just a few settings, there's not very much here to set up. First is this model location. Now if you want to change where the models are downloaded and stored, you can do that here. I created a new location, it's called LLMs. I'm going to put that there. And I'm going to go ahead and up this context length property just for the sake of it. And also I'm going to go ahead and put it in airplane mode. I'm not using Turbo or web search anyways, but I want to make sure all my data stays local in this environment and I'm not making any external calls out. So I'm going to set that there. Now over here, you can see from this drop down, this is the list of available models that you can get directly from this interface. To use any of these models, you'd simply follow the same process that you're going to see here. Now, not all of these models are downloaded by default. None of these are actually. So I'm going to simply select this GPT-OSS 20B model. And in order to start the download process, I can simply type anything here. I'm going to say, hey, hi, how are you? And click submit. And that's going to go ahead and start this download process. Now this model is about 13 gigs. If you're using the 120B parameter, that one's going to be about 65 gigs. So this will take it a few moments to download, and I'm going to jump back once this download is complete. Okay, and once the download is complete, you'll see that it then comes in and answers your initial response. So that's pretty good, and everything is up and running locally. Now, we want to jump back to Task Manager real quick, and you can see here this huge increase in the memory used by this model. So once it's downloaded and installed, it will load that whole thing into memory and consume that amount of memory. Now you can shut down Ollama, and then it'll release that memory back to the system. So for right now, it's consuming all that RAM, and I can go ahead and say, what is 2 plus 2? And it'll go ahead and think on that and give me a response. Now, this is very similar to any other interface we've seen, and you can see here the performance of this was actually pretty good. It ran pretty quickly for that. Now, the real benefit of this that I see is being able to interact with this programmatically, kind of via the API. So Ollama exposes an API that you can get access to. So let's take a look at that, and I'm just going to show how to call it via Postman. And the first thing you want to look at is the call here. It's localhost, and it runs on port 11434. And there's a whole list of the documented APIs that you can use with Ollama, which I'll let you check that out on your own. But the first thing we want to do is list all the models. So this will list all the models that are running in this environment. And you can see here it came back very quickly and showed me these models here. And you want to make sure you get the model name, because this is going to be used for other API calls. And let's jump down here and take a look at a request. There's two different ways to call into this model. One is to use /generate. The other one is to use /chat. And chat is our familiar chat model, and generate is just more designed to be a one-time request. So I'm going to go ahead and change this to my 20 billion version of the model, and I'm going to say what is 2 plus 2, just like I did before. But this time I'm going to provide system instructions that says when you see a 2, pretend that it's a 3. And I'm going to set reasoning level to low. In that system model, there's low, medium, and high. I think if I remember right, low is the default. And I'm going to go ahead and just run this request. Now this will take just a moment here. Now this is streaming, so if you leave it by default and the stream level is set to true, you'll see this think for a few moments and a bunch of streaming data gets returned to you. That wasn't useful for the purposes of this demo, so I set the streaming to false, so I'm just going to go ahead and get a response back right away. And sure enough, you can see here's my response back, and it came back with 6. This is exactly what we expected, because we told it to treat the 2s as a 3. And then here's the reasoning that it goes through to come through this, which is pretty cool to see how it goes through thinking through this step by step. Just to be complete, let's jump over here to chat, and again, I'm going to set the 20B version model. And here it's very similar to what we expect. We have system prompts, user prompts, a couple other different types of prompts that you can send in. If you're expecting to use past chat history, you'd have to pass that in message context yourself. It doesn't automatically do that, but it is designed to be an interactive chat interface that you could build your applications on. And again, I'm going to say 2 plus 2, but in this case, 2, I'm going to say it's going to be a 9. So let's go ahead and send this. And again, it's going to reason through this and think through it. It's going to take it just a moment to return our results. Now, some of the best use cases for this is now I can install this model locally and embed it in local applications that might not have access to the internet. So if I was doing edge applications, for example, that aren't always connected, it'd be a great way to be able to leverage this model and leverage some of these AI capabilities directly on my components. So this will take it just a moment. And again, the speed that this executes is going to depend on your CPU and GPU that you have running. Again, this is an Azure VM, so it's going to be a bit different performance than if you're running locally. When I ran this locally, it ran much quicker. And here, just as we expected, it came back with our result as being 18, which again, because we said treat the 2s as a 9 in this case. And then it gives our reasoning output here, much more reasoning level here than what we saw before, and then some other components at the bottom. So this was just intended to give you a high-level overview of how to set up and install GPT-OSS in your local environment. As I mentioned, this process exactly the same between the 20B version and the 120B version. Just make sure you have enough memory to do that full execution of that 120B version. So with that, I will conclude this demo, and hopefully you can see how you can use this locally for your projects. With that, don't forget to like and subscribe. Thank you.